How do greenhouse variables vary between Earth, Mars, and Venus? What are the consequences for the planet's climate and potential to support nature and life? Today we are exploring how differences in atmospheric composition and greenhouse gas effects shape each planet's climate, habitability, and future. Let's begin with a straightforward comparison. The Earth's atmosphere is primarily composed of 78% nitrogen, 21% oxygen, and minor concentrations of argon CO2, and other minor gases. This is what supports life.
Let us begin with Earth. Its atmosphere contains approximately 78% nitrogen, 21% oxygen, and 1% component of carbon dioxide, along with small amounts of other gases. This minor proportion of carbon dioxide plays a vital role. It traps the heat and maintains temperatures within a range to enable there to be complex life. Without it, Earth would not currently enjoy a temperature climate that is suitable for life, but would instead be an icy wasteland. Moving on to Mars, it also has a CO2-dominated atmosphere, about 95% carbon dioxide, but it is vastly thinner than Earth's. Surface pressure is less than 1% of Earth's, meaning it's practically a vacuum. Despite similar composition to Venus, Mars lacks the atmospheric density to trap heat. It is a cold, low-pressure desert world. Venus next. It is a CO2-dominated atmosphere composed of about 96.5% CO2. It's also a crushing atmosphere, more than 90 times that of Earth. It is equivalent to nearly a kilometer below sea level. For contrast, Mars has a very thin atmosphere.
And that leads us to one of the most important topics in the study of climate, the greenhouse effect. These greenhouse gases are referred to here included CO2, methane, and water vapor. They contain heat in the atmosphere of a planet. They keep us warm on Earth to the extent that allows for survival. But for Venus, the dense CO2 results in runaway greenhouse gases. There's no escape for the heat, and so it accumulates surface temperature of over 460 degrees Celsius. Even higher than Mercury, despite receiving less heat because Venus was farther away from the sun. Mars easily loses the heat that comes in because it's thin and cold.
The key factor in shaping a planet's climate isn't just which gases are present, but how much of them exist and the pressure they exert. These conditions are what truly determine a planet's environment, and by extension, the potential for life to survive or for robotic missions to endure them. This is especially important when considering the challenges NASA faces when sending probes to planets like Venus and Mars, where extreme atmospheric conditions can make even short-term missions difficult.
Let's start with Mars. Dry, cold, and dusty, but relatively accessible. That's why we've been able to land rovers like Curiosity and Perseverance, which have operated successfully for years. They run on either solar panels or nuclear batteries, and we use retro rockets and parachutes to land them safely. Of course, the thin Martian atmosphere makes slowing down during entry a challenge, but it's manageable. You can't breathe the air, but at least you're not dealing with crushing atmospheric pressure like on Venus.
Imagine putting a probe in a locked oven that's packed to capacity with acids and setting the dial to incinerate. The surface heat reached around 460 Celsius. It's also filled with CO2 fumes and aerosols of sulfuric acid. Probes like the Soviet Venera landers got destroyed and cooked with a bit more than an hour of the landing. And it doesn't frustrate hardware, it kills it. The question still remains why scientists even discovered the atmosphere in the first place, prior to sending a rover. The answer was spectroscopy, a technique which was established in the 19th century. Scientists examined light and reflected emitted by planets. The gases absorbed the light in patterns that are typical for them. Analyzing these patterns revealed Earth's atmospheric gases decades prior to when probes flew by. During the 1930s, the application of infrared made the presence of CO2 and water vapor in Venus and Mars atmospheres known to the astronaut Rupert Wildt. Robotic missions decades afterwards verified these findings. Radar imaging also is a very important factor in the scope of what we know about the exploration of Venus. With the cloud cover on Venus being so thick, visible light was very unable to reach to the surface. In a 1989 mission, Venus's surface was mapped by sending a radar to bounce the signal off the clouds and interpret the reflection back to the US. This is how we have knowledge of volcanoes and plains and other evidence of tectonic movements there without even seeing the surface. At face value, it's not a question of sending probes in or out, it's a matter of survival. Mars does not have shielding or pressure to support life. Venus contains the heat and pressure. There would be colonies there in domes or in cities in the upper atmosphere. Definitely a good idea one day. Venus and Mars can serve as cautionary tales. Venus shows what happens when greenhouse gases run wild, a scorched wasteland, while Mars shows us what happens when a planet loses its atmosphere entirely, and Earth sits in the middle for now. Comparing Earth to Venus and Mars reveals how fragile our balance really is. As we pump CO2 into the air, burn forests, and warm the planet, we risk tipping into a Venus-like heat trap or become barren like Mars. Venus, Mars, and Earth have these diverse climates due to their atmospheres, not only their composition but also their densities, and how their atmospheres interact with solar radiation. We have yet to plant a step on Mars or Venus, but we have learned a lot through remote sensing. Through the radar, it is harder to land a probe, but now we realize how special the Earth really is compared to these other planets. Looking at all these variables leads us to believe that there is no way we will be able to live on Venus or Mars anytime soon. Earth isn't a place we inhabit, it's the only home we inhabit. In the end, the differences in greenhouse variables between Earth, Mars, and Venus reveal just how critical atmospheric balance is. Venus, with its runaway greenhouse effect, becoming a scorching inferno, Mars, with a thin, fragile atmosphere, turned into a frozen desert, and Earth remains habitable because its atmosphere supports just the right conditions for now. But this balance is delicate, and if we continue to disrupt it, we risk pushing our planet towards the extremes we see in our neighbors, with devastating consequences for life as we know it.